Children, using the concept of bijective functions or composition of functions, let us see how to define inverse of a function. So there are two ways of proving or finding the inverse of a function. If we know that a function is invertible, then it has to be 1, 1 and on 2. Or we can say if a function is a bijective function, then it will be invertible. So a function is said to be invertible if it is 1, 1 and on 2. That is if it is a bijective function. You can understand from this diagram. See, it is a function from set A to set B, which is 1, 1 as well as on 2. You can see different element of set A are having distinct images in set B. So it is 1, 1. It is also on 2 because codomain is equal to range. Every element of the codomain is an image. Now, in this case, how inverse is possible? If I have to define inverse of this function f, obviously it will be now from B to A. And the way, suppose this element is x and its image was y. And say this was A whose image was B. And this is M whose image is N. Or P is having image Q. So under function f, when the mapping is taking place from set A to set B, we know the pairs. X will be related to Y, A related to B, M related to N, P related to Q. Now, if I have to define its inverse, it will be a new function from B to A such that Y will have image X, B will have image A, N will have image M, and Q will have image P. Now, you can understand why it has to be 1, 1 and on 2. Suppose 2, it was a many one function, 2 elements were having same image. Then when we will talk about inverse of it, it will not be a function either. Suppose x was having image y, a is also having image y. That means if I try to find inverse, y should have 2 images. That violates the very definition of function also. So in order that inverse is possible, it has to be 1, 1 and on 2. Now using composition of functions, let us see how inverse can be defined. So if f is a function from set x to y, then it is said to be invertible if there exists a function g from y to x such that composition of f and g is ix and composition of g and f is iy. The function g is inverse of f and is denoted by f inverse. Let us first understand this part. This we can come to know because if f has an inverse, obviously it will be from y to x. Coming to this part which should be satisfied for g to be inverse of f. Now the condition is composition of f and g is equal to ix. This is the notation for the elements of domain of f. Look at this figure. This is composition of f and g. So image of x is fx under the function f and image of fx is g of fx under the function g. So what do we find? When we define composition of f and g, it is a function from x to x. These two sets are same. This is set x, this is also set x. F is from x to y, g is from y to x. So what has happened? X is related to g of fx. This means what? This implies x is equal to g of fx. So this equation states that we should be able to prove x is equal to g of fx. Okay, so we are reaching the same element. See here, if I talk about this diagram and we are talking about inverse, x is having image, y is having x is having image y, y is having image x. So getting back to the same element. So you should be able to show composition of f and g is equal to the element of domain of x only. So you can see we are reaching there itself. In the same way, composition of g and f should be, and this is just a notation defining the element of domain of g. See, domain of g is here y. So we can discuss another diagram from here. For composition of g and f, mapping will take place under function g first and then it will take place under f. So we have drawn for g from set y to set x. Then we have drawn for f from set x to set y. Suppose the elements of domain of G are y. So image of y under the function G is gy, and image of element gy under the function f will be f of gy. Look at these two sets. These are the same sets. And what could we see? Y is having image f of g of y under the function composition of g and f. So they will be what? They will be the same elements. Okay, so y is coming out to be how much? G of f of g of y. So if we show that the image of y under the function composition of g and f is y only, then what happens? We are able to show that f and g are inverse of each other. So if you have to define inverse of any function, you should be able to define a new function. For function f, it is from x to y. You need to define a new function g from y to x, such that these two conditions are fulfilled. Then we are able to say that they are inverse of each other. G can be termed as inverse of f and can be denoted as f inverse. Even we can say f is inverse of g and can be denoted as g inverse.